Hello. So today we will start with a very short topic actually. So mutually exclusive and independence. Okay. Mostly we'll talk about independence, less on mutually exclusive. First, let us just discuss what these mean. Okay. So mutually exclusive basically means if two events, let's say A and B, are mutually exclusive, that means these two events can never occur at the same time. So let's say I'm saying A is a event where we roll the dice and we get even, and let's say B is an event where we get 5. Okay, so can these two events happen at the same time? Like, so let's say if I'm rolling a dice, right? So can we ever get 5 and even at the same time? No. So they are mutually exclusive events. A and B are mutually exclusive events. So for example, if I said 4, so if we got 4 for example, then that is not mutually exclusive. So there can be a moment where we can get even number as well as 4 at the same time. So here if it is 5, it is mutually exclusive. Okay. And what do you mean by independence? Okay. What do you mean by independence? Independence means the two events are not even related. A is rolling a dice and getting even, and B is rolling a 20 side die. No, let's say tossing a coin and getting head. So these two are not even related to each other in any sense, right? So like we don't even. So if we have an event A and if we have an event B, so in no way can A change the result of B. So if I'm rolling a dice or if I'm tossing a coin, right? So my coin toss does not depend on my rolling of dice. So that is basically my independence. That is the main difference. So this is mutual. So these two terms are very much confused between people. So this is the main difference. So mutually exclusive basically means two events that can never happen simultaneously. And independence means, see, it can happen simultaneously. I can roll a dice and toss a coin at the same time. But both of those events are not dependent on each other. As in, like, the result of A does not influence the result of B. That is the simple difference between the meaning of mutually exclusive and independence of a variable. So independence also means a simple thing. Okay, that P of EF, as in like P of E and F happening together, is equal to P of E into P of F. Now what is the proof of this? For the proof of this, we need to know something called conditional probability, which will be done later. The next lecture will be on conditional probability. So I wanted to do conditional probability earlier, but no, let's do a short topic so that you guys can also relax. So this is the condition for independence. So two events E and F are said to be independent if this equation holds, and if it does not hold, that means it is not independent. So basically P of EF is equal to P of E into F, but the equation changes a bit when we go to 3 variables. Okay, so when we go, this is 2 variables. Okay, 2 variables, and when we go to 3 vars, the equation changes a bit. So you would think it would be, let's say, G dot P of G. This was, I think this would be your initial thought, but this is not. So we also have to show that they are independent on their 2 variables as well. So it should be here, it should be FG here, and here it should be EG. So if these whole, let's say 4 conditions here, okay, 4 conditions are solved, that means it is independent. So you cannot say it is independent only with the one condition of all the 3. You have to also show that they are independent dually, then only you can say. So this is basically what the main part of independence is. Okay, so it does not make sense if we don't do examples. The main part of independence is just examples. So whenever you have given a question, right? So let's say if I am given a question, simple question: is this event are these two events E1 and E2 independent? Okay. So how do I solve this? Okay, how is E1 and E2 E1 and E2 are independent or dependent? So let's say, for example, if I take the E1 is the event where sum of dice is 4, sorry, sum of dice is 6, and E2 is the event where first dice is 4. Okay, so we are actually rolling 2 dice. Okay, so let's say we want to find P of E1 E2. So if it is independent, it should be P of E1 dot P of E2, right? Logically it should be like this. So let's do LHS RHS. So LHS is what? P of E1 E2. Now P of E1 E2 is what? So sum of dice is 6 and first dice is 4. So it should be 4 2. So it's only one possible thing, that is 1 by 36. Now what is the P of E1? Sum of dice is 6. So it is what? 1 5 2 4 3 3 4 2 5 1. So this will be 5 by 36, and P of E2 will be 1 by 6. So total will be what? 5 by 216, which is not equal to this thing. Is it equal to this? No. So this is not an independent event. So the only way to check if two events are independent is to use this formula. There is nothing other than this. So as I told, just find the LHS, find the RHS, and you have to prove if they are independent through this process itself. There is no other process that you can do. So whenever you are told ki, okay, this is this and this is this, you have to solve this according to that. There is no other option here. So basically this is the way of solving this, and this is a very short video. I'll end it here now, and you will have to, I'll give some problems, try to solve them, because there is nothing else I can do in problems. Every problem will be solved in this manner itself and no other manner. And let's move on to the next video the next day. Thank you.